Hello everyone, welcome to this video. In this video, we will be solving the engineering mathematics questions which were asked in GATE 2009 paper of aerospace engineering. In this slide, we can see that there were 10 questions asked in this paper, out of which 2 are 1 mark question and 8 questions were asked for 2 marks. So let's try to solve this one by one. Coming towards the first question, it is from the differential equation topic. So the question is the ordinary differential equation d2y by dx square plus ky equal to 0, where k is a real and positive. So this differential equation have what kind of roots is like this kind of question they are asking. So they have given options A, B, C, and D. The option A is a non-linear. Option B is characteristics equation with one real and one complex root. Option C is has a characteristics equation with 2 real roots, and option D is has complementary function that is simple harmonic. Okay, so let's try to solve this question. d2y by dx square plus ky equal to 0. We can write this in simplified form as d square plus k times y equal to 0. And we can treat now this f of d as a algebraic equation and we can solve it. So we'll get d square is equal to minus k, and hence d is equal to plus or minus root ki. Okay, so plus or minus root ki means 0 plus or minus root ki. So it is in the form of a plus bi, and whenever we get this kind of roots, we say it as a complex root. So both the roots are complex here. One is plus ki and another one is minus ki. So here we can clearly say that option B and C are incorrect, because option B says one real root and one complex, whereas option C says 2 real roots. Coming towards writing the complementary function of this differential equation, because since it is a homogeneous differential equation, it will have only complementary function. Okay, so total solution itself is a complementary function in this case. So, and that will be e to the power 0x c1 cos of root kx plus c2 sine of root kx. Okay, and we can simply write it as c1 cos of root kx plus c2 sine of root kx. Okay, so looking into this solution or this complementary function, we can clearly say that it's a simple harmonic. Okay, so comparing other options A and D, we can clearly say option D is correct in this case, because it says it's a complementary function and that is a simple harmonic in nature, and that is what's satisfying with our solution. So in this case, option D is correct. Coming towards the second question, this is from the linear algebra. Here the question is a non-trivial solution to n cross n system of equations. Ax is equal to 0, where 0 is a null vector, and they have given 4 options. When we can find this non-trivial solution, that is the question in this case. So whenever we see Ax equal to 0, it is a homogeneous system of equations. Okay, and whenever we come across a homogeneous system of equation, what we have to do is we have to check whether determinant of that matrix is equal to 0 or not. If determinant is 0, in that case we'll get a non-trivial solution. Okay, and if it is not 0, it means we'll get a trivial solution. The other words for trivial are unique or 0 solution, and other words for non-trivial are infinite number of solutions or non-zero solutions. So we are specifically looking for this case. Okay, non-trivial, which is asked in this question. So when we'll get the non-trivial solution? When determinant is 0. And when the determinant will be 0? The determinant will be 0 if it, when the product of eigenvalues is 0. Okay, so we have studied one property, product of eigenvalues is equal to determinant of matrix. If determinant is 0, it means product of eigenvalues should also be 0. And that is possible only when at least one of the eigenvalues is equal to 0. Hence, option D is correct in this case. Okay. If you look into the other options, can never be found, it is incorrect. Second option may be found if A is a non-singular. Non-singular means determinant is not equal to 0. So that is also incorrect, because for non-trivial solution, determinant has to be equal to 0. And the third option is orthogonal matrix, and that is also incorrect because we are talking about singular matrix. Okay, so in this case, option D is correct. Coming towards next question. This question is from the numerical methods topic. So the value of integral evaluated using trapezoidal rule with a 2 equal intervals is approximately. Okay, here they are asking us to solve this integration problem by using trapezoidal rule. So first of all, we have to figure out the function here. F of x is given as 1 upon 1 plus x plus sine of x. Now we have to create a table. They are asking us to create 2 equal intervals, and x is varying from 0 to pi. So the 2 equal intervals would be 0, pi by 2, and pi. And for these values of x, f of x will look like 1, 2 divided by pi plus 4, and 1 divided by pi plus 1. Okay, or 1 plus pi also we can write. So this is the given data. Now we have to apply trapezoidal rule here. Okay, so what is trapezoidal rule? Integration I can be calculated by using trapezoidal rule as using this formula h by 2 f of a plus f of x naught plus f of xn plus 2 times f of x1 plus f of x2 plus so on till f of xn minus 1. Okay, in this question, this is our x0, this is our x1, and this is our x2. This is f of x0, f of x1, and f of x2, and f of x2 is itself is equal to f of xn. Okay, nth term is second term in this case. So using this, let's try to put these values into this formula. H is nothing but the step size, which is pi by 2 in this case. So pi by 2 divided by 2 is pi by 4. F of x0 is 1. F of xn is 1 divided by 1 plus pi, and 2 times only the first term will come here, that is f of x1. So it is 2 divided by pi plus 4. Okay, so if you calculate this value using calculator, you will end up with 1.414. Okay, looking into the option, we can clearly say that option C is correct in this case. Okay, it was pretty straightforward. Coming towards the next question. This question is from the again linear algebra, where they are asking us to find the product of eigenvalues. We have just seen in the second question that product of eigenvalues is equal to the determinant of matrix. Determinant of matrix equal to product of eigenvalues. So if you know this, then solving this problem is pretty simple. Otherwise, you may have to calculate the eigenvalues and then take a product, and it will take a long time. So let's take a determinant in this case: 2, 1, 1, 1, 3, 1, 1, 1, 4. So 2 times 12 minus 1 minus 1 time 4 minus 1 plus 1 times 1 minus 3. So it will be 11 into 2 is 22 minus 3 minus 2. So 22 minus 5 it's 17. So looking into the option D is correct in this case. Okay. Coming towards the next question. This question is from the maxima and minima topic of calculus. So they are asking, in the interval 1 to 2, f of x is equal to e to the power pi x plus sine of pi x is maximum at which value, or whether it is monotonically decreasing. So this is what they have asked. So generally what we do, we take a differentiation of this function and equate it to 0 and get the value of x. Okay, but whenever this kind of limits are given, the simple trick is just put these values of x. Okay, because if you just try putting this value itself in the function, you will realize how the function is behaving. So I will write f of 1, f of 1.5 and f of 2. So if you calculate with this, what will get? E to the power pi plus sine of pi. Here e to the power 1.5 pi plus sine of how much? It's a 3 pi by 2, correct? And again here you will get e to the power 2 pi plus sine of 2 pi. If you look into the sine function, sine pi and 2 pi is 0 and sine of 3 pi by 2 is minus 1. So this is end up with 0 value. This is again ending as a 0 value. So and this is minus 1. So it is e to the power pi, e to the power 1.5 pi minus 1, and here it is e to the power 2 pi. So first of all, this value is greater than the first value, correct? The third value is greater than the first value. So option D is wrong in this case. It's not monotonically decreasing. And out of this value, we can clearly say that we are getting maximum value at f of 2. So maximum at x is equal to 2 is the correct answer in this case. Okay. Because if you compare the other values of function, it is pretty straightforward that we are finding maximum value at x is equal to 2. So option B is correct in this case. Coming towards next question, this is from the Laplace transform topic, and they are asking us to find the inverse Laplace of f of s. So we know that inverse Laplace can be found by different methods, like by partial fraction or by using convolution theorem. Looking into this question, it is clearly understandable that we can do the partial fraction here. Okay, so I will write f of s as s plus 1 divided by s plus 4 s minus 3 as a divided by s plus 4 plus b divided by s minus 3. And now if you we can write it as s plus 1 equal to a times s minus 3 plus b times s plus 4, and denominator will get cancelled from both the sides. Now let's put the values of s. If you put s is equal to 3, the first term will become 0 and you will end up with 7b equal to 4, and hence b is equal to 4 by 7. Similarly, if you put s is equal to minus 4, the second term will become 0 and you will end up with minus 7a equal to minus 3, and hence A is equal to 3 by 7. So if you put back this into the f of s, we will see it as 3 by 7 divided by s plus 4 plus 4 by 7 divided by s minus 3. And now here we can take 3 by 7 as consider it as a constant, and it is 1 upon s plus 4 plus 4 by 7 into 1 upon s minus 3. So this is our f of s now. And if we take a inverse Laplace of this, we know the property that inverse Laplace of 1 upon s minus a is equal to e to the power at. So using that logic, we can say f of t will be equal to 3 by 7 e to the power minus 4t plus 4 by 7 e to the power 3t. Okay, and looking into the option, it is clear that option B is correct in this case. Okay, yeah. Coming towards next question. This question is from the linear algebra, where they are asking us what kind of solution we'll get for the system of equation Ax equal to B. So what the Ax equal to B is a non-homogeneous system of equations, because we don't have a equal to 0. We have some term B on the right hand side, and whenever we deal with a non-homogeneous set of system of equation, either we'll get consistent results or inconsistent. So on what basis we decide? We calculate the rank of matrix A and the augmented matrix AB, and if the rank of A and rank of AB is same, in that case we say that this linear system of equation is consistent. Okay, and if it is not the case, then we will say that it is inconsistent. And whenever we have inconsistent case, we'll have no solution. But if we have a consistent case, depending on whether our rank is equal to number of unknowns or rank is not equal to number of unknowns, we'll have either unique solution or infinitely many solution. Okay, so this chart will clearly help us to solve this question. So the first step you will do here is make an augmented matrix AB. So which is 1, 2, 2, 4, a dotted line, 3, 3. And we have to find now rank of this augmented matrix. And how we find the rank? By converting the given matrix into the echelon form. So let's try to convert this into echelon form. So we'll try to make this 2 as 0 by performing an operation R2 is equal to R2 minus 2 times R1. So what we'll get? 1, 2, 3. First row will remain as it is. 0. 4 minus 4 is 0. And 3 minus 6 is minus 3. So now we can clearly see this is the matrix A. And for matrix A, the rank is equal to 1. And whereas for rank of matrix AB is 2, because the overall matrix is 2 and number of non-zero rows are 2 here, correct? Because now we are considering entire matrix. So there is inconsistency. Rank of A is not equal to rank of AB. Hence, it will have no solution. Okay, hence it will have no solution. So option A is correct in this case. Okay. Coming towards the next question. This question is from the numerical methods. They are asking us the iterative formula for finding the square root of positive real number R. Okay, so we have to create the iterative formula in this case by using Newton-Raphson method. So what is the iterative formula for the Newton-Raphson method? Xn plus 1 is equal to Xn minus f of x divided by f dash of Xn. Okay, this is f of Xn here. So in this case, it is clear that we should know what is function f of x and what is the derivative of that function. So let's try to find out what is function they have given. They have given as square root of positive real number r. So x is equal to under root r. So we can say x square minus r or x square equal to r. And hence x square minus r is now our f of x. And what is f dash of x? It is 2x. So now using the iteration formula, which I have given in this equation 1, let's try to create it in the form of xn. So xn plus 1 would be xn minus xn square minus r, which is now f of x here, and f dash of x is 2x, so I can write here as 2xn. If you further simplify it, it is 2xn square minus xn square plus r divided by 2xn. And it will be xn square plus r divided by 2xn. You can take 1 by 2 as a constant outside, and inside the bracket, if you break it here, you will end up with xn plus r divided by xn. Okay. So the iteration formula will look like this. And let's compare with the options. Yeah, it is same as option B. Hence, option B is correct in this case. Okay. Coming towards next question. Yeah, this question is from, this is the link question, this 53, and I have one more question on next page, which is 54. They are linked together. And this question is asked from vector calculus topic. So let's try to solve it. Consider a vector field A bar. A bar is given as y cube plus z cube I plus x cube plus z cube j plus x cube plus y cube k, defined over a unit sphere, and the equation of sphere is also given, x square plus y square plus z square equal to 1. Okay, what is the question here? The question is the surface integral, okay, taken over the sphere, means it is a closed surface, that's why I'm writing this symbol. Okay, of the component of a bar normal to the surface is, so a bar dot n cap ds is equal to what they are asking. Okay, here we can solve this question very easily by applying Gauss divergence theorem. What Gauss divergence theorem says is we can convert the surface integral into the volumetric integral. Okay, by in case if we have the closed surface. Okay, and that is what satisfying our criteria here. We got a sphere which is closed surface. The meaning of closed surface is it should not have the edges, and sphere don't have any edges, hence it's a closed surface. And now according to the Gauss divergence theorem, the surface integral is equal to the volumetric integral of divergence of a bar. Okay, so this is the equation for the Gauss divergence theorem. And in this case, the LHS is what they are asking. So if you are able to find the RHS, we can say that the value of that surface integral can be found. So the A bar is given here, and we have to calculate now divergence of AR, divergence of A bar. What is divergence of A bar? It is dou by dou x of I plus dou by dou y of j plus dou by dou z of k, and dot product with a bar. Okay, I'll not write a bar again, but we can clearly see we have to differentiate first term with respect to x, differentiate second term with respect to y, and differentiate third term with respect to z. And looking into the a bar, it is pretty clear that first term is not consist of x, second term is not consist of y, and third term is also not consist of z. Hence, divergence will be 0 in that case. Okay, and integration of 0 is 0. Hence, the answer for this question is 0. Okay, so option C is correct in this case. Okay, so what we have done this in this problem is just use the Gauss divergence theorem and converted the surface integral into the volumetric integral, where we have calculated the divergence of the given vector and it is 0. Hence, it was very easy to solve. Coming towards the next question, this is again the link question with the previous data. The question is magnitude of component of a bar normal to the spherical surface at point 1 by root 3, 1 by root 3, and 1 by root 3. Okay, normal to this spherical surface. First of all, let's try to find the normal to the spherical surface. The spherical surface is x square plus y square plus z square minus 1 is equal to 5, we can say. And normal to this is just if you take a gradient of this phi, we'll get a normal to the surface. Okay, because we know that gradient is normal to the surface. Okay, so you will take a gradient of it. So you'll operate a del on this scalar quantity and you will end up with 2xi plus 2yj plus 2zk. Okay, so first step is we have calculated the n bar. N cap in this case is a unit normal vector, and that will be 2xi plus 2yj, or I will say it as n bar divided by mod of n, which is magnitude of this vector. So it is 2xi plus 2yj plus 2zk divided by mod of n is under root of 4x square plus 4y square plus 4z square. And in this case, what we can do is 4 we can take common. Under root of 4 is 2. And again, the remaining term is x square plus y square plus z square. And we know x square plus y square plus z square is 1. So in denominator, you will just end up with a 2. So mod of this n is 2. And unit vector would be xi plus yj plus zk. Unit vector means with a magnitude 1. So this is the first part. Coming towards the question, the magnitude of component of a bar normal to the spherical surface. So this is the direction of normal. So this is the normal to the spherical surface. Okay, so let's try to visualize this. Let's say this is your a bar and we got some another vector n bar here. Okay. Okay, for example. And now what they're asking us is magnitude of component of a bar in this direction, in the direction of n bar. So let's say theta is the angle between them. And now if you project it here, okay, so this is now, let's call it as A1. Let's call it as A1. Okay, here in this case, A1 is what? A1 is a component of a bar in the direction of n bar. Okay, and I can write A1 as mod of a cos of theta. So this is a scalar component. Okay, it's not a vector, it's a scalar component, we can say, as if now, because we are not written, we are considering magnitude here. Okay, and we also know that cos of theta is equal to a bar dot b bar divided by mod of a into mod of b. Okay, so this is theta is the angle between these two vectors. So if this thing is known, here we are talking about a bar and n bar. So let's write it as a bar and n bar to make it more realistic with this problem. And now I can write as mod of a cos of theta is equal to a bar dot n bar divided by mod of n. So you can now replace here with this. So we can write it as a bar dot n bar divided by mod of n. So this is again the scalar component in the direction of n bar. Okay. And what is the vector component? So a1 bar would be equal to a bar dot n bar divided by mod of n, okay, into b cap. And what is b cap here? B cap in this case is unit vector, or let's call it as n cap. Okay, n cap is the unit vector in the direction of n bar. So now this is what we can say as a component of a bar in the direction normal to the spherical surface. So this is a component of a bar normal to the surface of sphere, okay, or spherical surface. So this is just a theoretical background which you should know before solving this question. Let's call it as equation number 1. N cap, you can write it as again n bar by mod of n. Okay, so we already know the value of mod of n, we already know the value of n bar, we also know the value of a bar. So you just have to take a dot product here and solve it. So I'll go to the next page now, and let's try to calculate here a bar dot n bar at point 1 by root 3, comma 1 by root 3, comma 1 by root 3. That is what they have asked in the question. Okay. So if you see what is a bar here, a bar is y cube plus z cube. So it is 1 by root 3 cube plus 1 by root 3 cube. Okay. And same for second term and third term. N bar is 2x. So it is 2 into 1 by root 3. So the dot product will look something like this. 2 by root 3 into 1 by root 3 cube plus 1 by root 3 cube. And this will repeat 3 more times. Okay, sorry, 2 more times. So I will just multiply with a 3 to make it more simpler. So if you solve it, it is 2 by root 3. 1 by root 3 whole cube is 1 divided by 3 root 3. And plus again 1 divided by 3 root 3. It is 2 divided by 3 root 3. Multiply by 3. So this 3 will get cancelled, and you will end up with 4 by 3 as a dot product. So considering this equation number 1, we can say that a bar is equal to 4 by 3, which is a bar dot b bar divided by mod of n. Mod of n is 2. We have already calculated. If you remember here, we have said that this is equal to 2. Yeah, here we have written. And we have one more mod of n in the denominator, and we got n bar here. So n bar is 2xi plus 2yj plus 2yk divided by 2 here. Okay, so in this case, this is 2 multiplied by 4, and it will get cancelled out with this 4. And from this numerator part, we can take 2 outside. So it's a 2 by 3 times xi plus yj plus zk. This is our A bar. Okay, but the question is magnitude of the component of A bar. Okay, so this is our A bar in the direction normal to the surface. Okay, but they are asking magnitude of this at 1 by root 3, comma 1 by root 3, comma 1 by root 3. So if you put this 1 by root 3, 1 by root 3, 1 by root 3 here and take a magnitude, you will again end up with a 2 by 3. Okay, why? Because this 2 by 3 is anyway constant. Okay, you will take it outside. Under root of x square plus y square plus z square will be the magnitude of this vector, correct? And how much it will be? It will be under root of 1 by root 3 square plus 1 by root 3 square plus 1 by root 3 square. Okay, and it is 1 by 3 into 3, 3 will get cancelled, so it's 1. And if you remember, we have already seen this is a unit vector also, so you don't have to even perform this operation, and you can directly tell 2 by 3 is the magnitude of the component of A bar normal to the spherical surface. Okay, hence option B is correct in this case. So that's all about this 2009 paper. Thank you all for watching this video.